Hi guys, let's continue talking about reinforced learning. We develop environment and let's create an agent for reinforced learning. So, first we need to import a few libraries like TensorFlow and DQL from collection. DQL is useful for create a queue and to work with array. In array we store some memory from experience of environment. And we use a TensorFlow to create a neural network. Also, we use library random to create some random action to find some relationship and do some explore environment from reinforced learning. And NumPy we use for work with array. So this is a class DQL agent, and we do some initialization. We take several arguments. The first argument is gamma. Gamma, if a value close about 1, it means our agent don't want delay of reward. But I recommend to use it gamma about 0.5. It means our agent would be delay for reward to deep understand what reward could take agent in the future. It's important. So next one argument is a neuron of neural network. We could use 24 neuron, and you could increase this number of neuron, but usually I increase number of neuron depend on what environment we use. Also we use optimizator. By default I use Adam optimizators, but sometimes I use RMS-Probe. But it's part of tuning of neural network. It depends on situation. Learn rate, it also we use in neural network, and it depends on situation, and it's useful for deep understand our gradient from environment. Okay, so finish we use for control our reinforced learning, and environment, it means our environment. So epsilon, it is argument to do some explorer of environment. If epsilon very high, our agent could take some random action to explore our environment. If epsilon is decreased and become about 0.01, it means we do more predictional from our agent. But we could this value could be flexible, depend of situation. Epsilon decay, it means we do multiply on epsilon, and when we run, when we learn our reinforced learning, we decrease our epsilon. Okay, batch size by default we use 32, but it also depends on situation. We could tune on this value. It's same about memory. Using DQ from collection, we create an array when we store data from learn of agent. Also we use observation space. It means what is the number of feature we use to our neural network, and what feature we analyze. For example, we could analyze last 5 bars or last 50 bars. We should explore it and try different options. And in this one we create argument of model, and we build a model from this private method, and we input number of neuron, optimizer. By default we use Adam optimizer, and learning rate. By default we use learning rate 0.001. Okay, we start build neural network. It's a simple neural network for reinforced learning, but we also could change this neural network and create more smarter. But let's start from easy to hard. Okay, we define our neural network. It's input layer, and we input our 24 neurons and input dim. It means number of feature what we analyze. And by default we should use activation function relo. It works fine. Hidden layer is next layer, and we also use activation function relo and input the same number of neuron, but we also could change parameters of neuron. I mean, it could be neuron less than here or vice versa, and it depends of situation. We have many parameters for tuning and how to improve our agent. And output would be number of action, and we use activation function liner. And for activation of this function we use mean square error like loss function, and to indicate our optimizer it is Adam with our learning rate. When we work with reinforced learning, we need to save this model and load it again when we would like to predict some action on production, or when we would like to test it. Okay, so next it is let's hide this value. Next it is action. So the first thing what we need to understand, we should balance between explore and make prediction in our agent reinforced learning, and we control this situation using epsilon. If epsilon is decrease, it means we do more prediction from neural network. If epsilon is increased, it makes we do more random actions to understand more deep our environment and do some explore. So we should find some balance here using epsilon. When we do some action, we have some results from environment what we did it before. I mean, when we do some step, we return a step state, what state exists on this moment, what reward, and done. Also additional information from this step. But default is dictionary empty, but we could improve it in the future. So let's replay. We do some random sample from this array DQ, and we indicate that we would like to have 32 values len, and we create some batch, and we extract batch on this value, because we input value here, and it would be state, action, reward, next, and done. And we need to loop this batch and learn and train our model. So we calculate a reward, and we use gamma to control of delay of our reward, and here we predict our action and the calculation some reward. And target in this part we solve equation Bellman. This guys has some formulas he creates this formula to solve reinforced learning problem. So we create value target, and we create this state, and we need to fix this target using that we have those action, and we input this reward, and we need to feed our neural network that if we have this state, we get some reward from our target, and we indicate that we would like to have one epoch and were both false. It means we hide additional output information when we train agent, and also we decrease our epsilon. It means we do more prediction from reinforced learning. Okay, next let's learn our reinforced learning. We input one argument is episodes, means epoch, and we calculate empty list of our total rewards. Let's loop this epoch when we learn our neural network. So we create state on some moment. Let's see what is the step, what is mean. Step, you could see what is mean reset. We reset all data, and we start from this bar. It means if you use look back, let's see what is look back. By default we indicate some look back, how many bars we analyze in the past to create some feature, to create some action. And where is so we do some state and using environment, and for machine learning we need reshape this data in this format, and for reshape our array we use NumPy library and method reshape. We input like first argument our state and indicate what shape of data we would like to have. Next we loop all our data from environment. This is our data frame, this price of Bitcoin in this case, and if we have this state we should make some action from here. If we have this action, we do some step from environment function. Let's see what is step from environment. So when we have some step, we calculate accuracy and return state, reward, and additional parameters for learning. Okay, and we need to store all this data. The main data, it means what is state on this moment, what is action, what is reward, and what would be next state of market. And done, it means for parameters for train. It is both parameters, I mean true or false parameters for train our neural network. Okay, so next we indicate that state would be like next state. It means because we loop our data and we need to process all these parameters, and if done, it means let's see, I would like to show you. I remember what is mean done. We define in the step function. We have several rules to define done to train our reinforced learning models. And if we have this situation, we calculate our reward and print our reward. But we need to calculate also average reward by one epoch to understand more deeply how it's working. And if this is also additional rules, it means if you have enough data in memory, and we could take 32 length of this array, because the batch size 32 by default, and we could train our neural network. And also the most important, after learn our reinforced learning algorithm, we should save this model. And a similar logic for test data, but before we need to load this data and define that epsilon should be 0, because we would like to only predict data and we wouldn't like to have some random action. We calculate total rewards, and we start from inverse set. It means we start from the first state and do a loop for our data frame and calculate our backtest events. So when we did it, we could create a new file like run agent, and we import our environment from this file. We import our agent, and we also import matplotlib to plot our data. And let's do it, and would like to show you how it's working. For example, let's run it, and here we could get data from binary server, and you could check it, what is mean, what is environment. It means I would like to get data Bitcoin USDT, and I would like to analyze on the closed data, and I would like to analyze last 4 bars. But we could use it, for example, 5 or 10 bars. It depends of situation, and this is too many work to have some research how it's working and find the best way to solve trading problem. And I would like to demonstrate. For example, let's learn it, and we create object of class, and indicate the gamma should be 0.5, and indicate our environment, and we learn our agent. Okay, and this is only for your demonstration. I take only 10 numbers of epoch, but the most important thing what you should to know, it you need to understand that we increase total reward for each episode, and we should to see that our reinforced learning algorithm could learn and could find some relationship, and we could use it for test. And for test data, and let's do plot, but in this case, if we plot data, we're looking for this only for this data, because I run on a few episodes. But if you run on 100 episodes or more, you see many of trades, but it takes some times. But you could see more better results with multiply of trades. And for test you also could run this method like here, and we need to indicate that would be 1. Okay, let's see what happens, and let's run for test. And you see we couldn't learn this algorithm because we have a very small of episodes, but run for multiply of episodes. But I already have this model for 100 data. Let's copy paste these models. I need this copy paste. 1 second. If I run this one for new model, let's see what results do we get. Okay, let's run it again. So if I run it for 100 episodes, you could see the results is better, but if we run on more episodes, we could improve this results. And we have multiple way to improve these results. The easy way to tuning this neural network. More harder way it's do more complex environment and more complex agent. And let's talk about it in the next video.